Hello students, so we're going to continue on chapter 3 part B video, starting from this detecting outliers, right? Outlier is usually very small, unusually small, or unusually big number, right? Unusually small, unusually big number. So data value, if we convert any data into the z-score value, if it's less than -3 or greater than +3, then we consider that as outlier. So sometimes it's just incorrectly recorded. Sometimes when someone typing in those data into a computer or like Excel file, they externally didn't put the period or so that's sometimes why we have these outliers. So um, let's say the apartment rent um, um, data. If we convert all the data into the z-score, and we have this result, right? We have this result. So smallest z-score is being -1.2, the largest being 2.27, means that this is within ±3 the outlier interval. So it looks like none of the value is actually outlier in our apartment rent data, right? Uh, Exploratory data analysis um, procedures enables us to simply arithmetic and easy to draw picture um, to summarize the data, and we can also use what's called the 5-number summary and the box plot from the 5 numbers. So let's take a look at what are those 5 numbers. 5 numbers basically consist of these 5 numbers: smallest number, largest number, the median, which is the middle number, and first quartile and third quartile. So these are pretty simple. Let's say in our smooth the blackboard, let's say you have a data set arranging from here to here. Let's say this is the smallest value, say this is the highest value, and smallest value itself is one of the 5 number. Highest number itself is going to be one of the 5 number. Also we had the median, which is the middle number right here, and middle number of the first half, this one is called Q1, the first quartile. The middle of the second half, the middle number, the median of the second half, is Q3. So small, Q1, medium, and Q3 and high. These are going to be what's called the 5 numbers. Right? These are these numbers right there. So our apartment rent data point, if you line them up from small to large, of course we had lowest value, smallest, largest value right here, 615, and we have the median. Since we have an even number of data point, the middle of these two, which is still 475, is the median, and the middle of the first half, which is going to be Q1, the first quartile, middle of the second half, 525, is the third quartile. So these 5 numbers. Now box plot is a simple form of graph that we can have using those 5 numbers. So it looks like this. It ranging from, remember that smallest number is 425, so 425 right here, and the large number was what? Large number is 615. So 615 is about here, right? But what you actually graph is the Q1 value, the Q2 value, Q3 value. So Q2 being right in the middle, 475, Q1 being right here, 445, and Q3 being 525 is right here. So this gives you what? This gives you the middle 50%, right? Middle 50% right there. So, box plot looks like this. You have scale from the roughly the smallest value to the largest value, and you make a box from Q1, Q2, Q3, just like that, right? That's a box plot. And there is another term, what's called the IQR, the interquartile range. Interquartile range is basically this. Interquartile range is Q3 minus Q1. That's interquartile range. So IQR, let me write it here. IQR is what? Q3 minus Q1. That's interquartile range. So in our case, this is another technique of figuring out the outlier in our apartment rent data point. You set up these two limits. Lower limit being from Q1 you do minus 1.5 times interquartile range. Interquartile range, that as I told you, is the Q3 minus Q1. So Q3 was this minus Q1 is this, which becomes the 80. So that's why the IQR is being 80 right there. So Q1 minus 1.5 times IQR being 325. Upper limit is Q3 plus 1.5 times IQR being 645. So we set up these two intervals. Any data point outside of this interval is considered as outlier in our apartment rent. So it's 325, 645. There's no outlier in here, right? All the data points are actually within these two intervals. But if there is a point that's not included within this interval, then we consider that as outlier. So box and whisker plot. The box plot was this box, right? Q1, Q2, Q3. Q1 the median, the Q3. Box and whisker plot, we have the whisker part. The dashed line is the whisker part from the smallest value to the largest value. So from here to here, you have this dashed line. So they usually do this together, not just the box. They usually do box and whisker plot. So you have dashed line up to Q1, from Q1 to Q2, Q2 and Q3 make a box, and from Q3 to the highest value we make another dash line, which is a whisker part. And these are some of those examples of box and whisker plot. Notice that you have this couple of stars point right there, right? So this is unusually high or unusually low numbers that you want to not include it in this box and whisker line. You rather have a separate point like that, right? Okay, now let's talk about weighted mean. Weighted mean. Weighted mean is a technique of calculating mean, which is the one of the average, right? As you know, but different data point has different worth, different weight. Then we use this weighted mean technique to figure out the solution. You know, we use this when we are calculating like GPA, when we calculating our final grade. You know, when we have a different weight for different types of exam, like midterm and the final, they all have different weight, right? So we use this weighted mean to figure it out. Now this is the formula. So x bar sample mean is sigma means what? This sigma means summation. The W part is the weight. X part is the score. So summing up W, the weight times the score over the summation of the weight. And that's basically the weighted mean formula. So, you know, let's check out this example. Let's say, suppose your midterm score is 83 and your final score is 95. And your midterm is 40% worth and your final exam is 60% worth. See, this 40%, 60%, different proportion, different weight. And you need to get minimum 90 to get an A. If your score looks like this, are you getting A? That's the question. So you need to calculate the weighted mean. So going back to this, the weight times the score. The weight times the score, right? So which one's the weight? You know, 40%, 60%, that's the weight. What's the score? 83, 95, these are the score. So the score x times the weight plus x times the weight over sigma weight, adding all the weight. Then if you calculate that, you have 90.2, which is above 90, so you end up getting an A for that course, right? Now, there's an example 5, another example for calculating GPA. Let's say your report card looks, let's say your friend's report card looks like this. So English 1, 3 credit, got an A. Intro to Psych, 3 credit, got C. Biology 1, 4 credit, got B. And Physical Education 2 credit, got D. So which one's the score and which one's the weight? Of course, the credit points weight, different worth, and grade is going to be the score. So if you put it in that formula, it looks like this, right? W times the X. W was the credit, X was the score, right? So 3 times 4, W, credit times the score, 4, right? 3 times 4 plus 3 times 2. This was for the intro to psychology, right? Now, 4 times 3, that's for the biology, right? 4, weight 4, the score 3. If you keep adding it up, divide by the total number of weight, which is total GPA, it becomes 2.7. So that's how they actually calculate GPA, right? That's how they calculate GPA. All right, that's the end.